So for continuous growth and decay, we're using the same model, except now the time can be in any value. It doesn't have to be years. So whenever we're talking about money, we need time to be in years because the interest rates are annual interest rates. But now the rate is going to decay or grow in whatever unit of time that we assign to the problem. So the rate is positive when you're growing. The rate is negative if you're decaying. A naught is the initial quantity at time 0, and T can be any unit of time. So let's look at how to do a problem like this. Jen really hates spiders. Her house is infested and her exterminator tells her that the pesticide has a continuous kill rate of 0.9%. So this is a kill rate, so it's a decay rate. So I have to convert the rate into a decimal form of this percentage. So I divide by 100 and I have to make it negative because it's a decay. So it's 0.009. It says if the exterminator estimates that there are 10,000 spiders in her basement, how long until half the spiders are gone? Round your answer to 2 decimal places. So the first thing we need to do is build the model. So she's starting out with 10,000 spiders, and they're decaying at 0.009 T. And we want to set this equal to 5,000 spiders. So we can do this in our calculators. We go to y equals. We're going to put our new model in, 10,000 e to the negative 0.009x. And then we're going to set y2 equal to 5,000. So I'm going to hit graph. All right, so we're not getting anything. This is being measured in hours. So right now I'm only looking at 10 hours. So it definitely is taking longer than 10 hours to kill these spiders. So let's take this out pretty far. Let's just go out like 100 hours and then zoom fit and see what happens. Because it's killing them very slowly. 0.9% isn't very fast, so we'll go pretty far out and see what happens. So now let's find the intersection. And we see it's 77.02 hours. So this is the answer. And just for a little perspective, if you convert that into days, it takes a little bit longer than 3 days, almost 3.5 days to just reduce it by half, right? So B says, well, how many spiders are in her basement 24 hours after he sprays the pesticide? Round your answer to the nearest spider. So if I want to know what's going on 24 hours later, I just go to second calc value and plug 24 into my function. And we see it's 8,057 spiders. So technically it's 8,058 because you can't have 0.3 of a spider. So that means we've got one spider like in the middle of death at that point. Find the hourly percent rate and round it to 2 decimal places. So we want to know how many spiders are dying every single hour. So since we're measuring the time in hours, that's the same as the effective yield rate. So it's just e to the negative 0.009 minus 1. And that gives you negative 0.00896. So if we convert that to a decimal, that's negative 0.896%. So every hour it's killing just a little bit less than the overall kill rate